Very good evening, students. Welcome back in our third session, data science session. So, welcome to Cybervidyapeeth Foundation, and today we are going to learn about some important function of Numpy. In previous class, we already discussed about pandas important functions or method. So today we will see about some functions, important functions of Numpy. So I'm waiting more 5 or 3 minutes. After that, we will start. Okay, so students, I'm starting with Numpy. So exactly what is Numpy? So that's a question. So Numpy is general purpose array processing package, and it provides a high performance multi-dimensional array objects. And it's a tool for working with those arrays. And also you can say that it is the fundamental package for scientific computing in Python. Okay, so it's a open source software. And also what is the installation process? So it's very simple. Yes, inside your Python version, if NumPy is not available, then install it with the simple command. That means pip install NumPy. Okay, and after that, NumPy will install in your inside your Python is a package. So let's start with some array, NumPy array. Okay, so at first we import NumPy as np. Now I'm creating an array. Okay, yes. So how can I create that? np dot, that means numpy dot array. So this is a function, and this function will create a two-dimensional array. You can create one-dimensional array. Okay, so I'm creating here a two-dimensional array. All of you know that how can we create a two-dimensional array. So double square bracket, inside it the first row, after that the second row, like this. Yes. So now at first we are going to see what is its type. Okay, so I am simply printing the array is the type of, yes, I'm using here the type function, and inside this parameter here is our array. So let's see what is its type. Okay, so yes, we can see that it is a NumPy in dimensional array. Already we see in the previous class, but NumPy has more and more functions and methods that we are going to use for some other purpose. So now if we want to see how dimensionally, so we can easily check that number of dimension. Yes, simply it's a method, and right like this, it will print that how dimensional this array. Okay, so if we print, yes, the number of dimension is 2. So all of you know that this is a 2 into 3 matrix. Okay, so after that we want to see its shape, and already we know that how we can see the shape. So again I'm repeating, shape of array, just simply array dot shape. Yes, the shape is 2 into 3. Okay, and after that if we want to see the size, so you can easily call something like this, the size function. So size is dot size. Yes. So what is the size? 6. We can see that the array size is 6, and this is the simple method we're using here. So we need this type of function inside our project. Okay. We want to see its data type. Okay. That means, is it a string? Is it an integer? Or is it a float type? So that all the things is under the numpy. Okay. So there I am not calling the pandas module, but so you have to understand that it all this function or method is under the numpy. Okay. So let's say array, suppose something like this, store data type, it means array dot d type. Yes, this is integer 64. So this is the introduction, simple. We are using this kind of methods or function. So now, how can we create an array? Okay, so after that, I'm going sequentially. So our next is array creation. Okay. So inside this array creation, we have a lot of function. At first, we will see that something like this, that whatever we do here, yes, that means simple. We can create array with this array function. Okay, and we can also declare its data type. Okay, so if we write here that d type is a parameter of array function. So if we write t type is, suppose I want to float 64. Okay, so only float. Okay, after that, if we print suppose array created, yes, so using a list, so all of you know that it's a list. Yes, using a list. After that, I'm calling a, or call, yes, arr, because my variable name is array. Okay, now we will see output that array created, yes, using a list like this. Okay, so wait here. Yes, this is our array already created. But after that, if we create like this is another process, that numpy dot array, and we are creating an array from a tuple. Okay, so how can we create? So all of you know that the tuples start with first bracket. Okay, so this is our arrays function parameter. Inside this, I'm creating a tuple like this 1, 2, 3. Okay, so if we print that array created using tuples, yes, and simply call the array. And we can see that here is our array is 1, 2, 3. So from tuple to a numpy array. Okay, so I think it's clear. After that, we want to create some array with all the elements value is 0. Okay, so suppose t is equal. So how can we do that? Simply call the zeros function. Yes, that is the function, and inside it you have to initialize the dimension, the size of the array. So if we give it that I want a 3 into array, or you can say matrix. So after that, if we print that an array created with all zeros, and here simply comma and d. So yes, we can see all of the zeros value. Okay, after that we want to create an array initialize with all suppose complex number, with some complex number, and 3 into 3, its size suppose 3 into 3. So how can we keep? So this is another function of numpy. Suppose I keep here f is a variable. After that, np dot, there is a function that is full. Okay, so function is full, and inside this function I am giving the size that is 3 into 3. After that, I want to initialize with all 6s array. Okay, so inside this parameter I'm giving 6, and after that I want to its data type. Okay, I want to its data type complex. Yes, so I need a complex number. Okay, just a second. Yes, after that now we want to print it, and simply we write that an array an array created with initialize with all six arrays and the type is suppose complex like this, and I want to print the arrays, that means f, because it's inside this f, and here we will give a yes like this. So we can see that this is a 6 plus 0.j. That means it's a complex number. Also, there is a complex number. So that means our value is 6 and it's a complex number. Okay. So for if I anything you can write here, that means 7. Yes. So the complex number with 7 like this. So after that, there is a nice, and it's a most important function, that is random. So random is actually create some you can say matrix with some random values. Okay, so this is too important, because where we haven't any data set, suppose we need an extra column, but we haven't any values inside this column. So in this case, we can use some random function, okay, with its range. That means I need thousands random values, this to this. Okay, so I will show you this random function clearly in the next class, where we will going to solve some mathematical problem, simple mathematical problem. So let's see a simple example of random function. So like this, random dot random, okay, random dot random, and inside this parameter I am giving the size of the matrix. Okay, so after that, if we print that yes, a random array, so like this, yes, oops, so if we give a /n, so it will print after one line. Okay, so that's why we are using this end line. So now we are printing simple r, and here you can see some random values. Okay, so you just see this is 5931837. So if we again run this cell, you can say this is 39131758. That means this random function is creating random values. If we again run it with shift enter, so you can see here again 5423, something like this. Okay, so I think it is clear to all of you. Yes. So after that, we we're going to create a sequence of integer from suppose 0 to 30, okay, and with its steps of 5. So let's see how can we do that. Suppose s is a variable and inside it, so look at here what exactly we learned. We using array function, after we use zeros function, full function, random function. So just remember the working method of those function. Okay, so now I'm showing you a important function that is arrange. Okay, so it will arrange a data set or arrange a matrix element, suppose there to there. That means from you can create 0 to 30, 0 to 50, 0 to 100 with a steps of, suppose difference is 10, 5, you can initialize uh, 20, something like this. Okay, so inside this arrange function, suppose we want to 0 to 30 and steps is 5. Okay, so if we print that, if we print this array, so let's see, that is yes, like this, a sequential array with steps of 5. So a sequential array with steps of 5. Okay, after that end line, yes, after that we are printing our array. So we can see that 0, after that 5, after that 10. So the difference with each element is 5. If I give here 10, yes, we can say 0, 10, 20. If I give here 100, yes, so 0 to 100 difference with each element is 10. Yes, that's cool, I think. So this is the working method of arrays. Okay. Now, a most important thing, that is linspace. Okay. So it's actually returned evenly spaced value within a given interval, um, or you can say number of element returned reshaping array. Okay, so how can you do that? Suppose I'm starting with a variable g, and inside this I'm creating a np array like this, and I'm calling our function that is linspace. Yes. Okay. And after that, so it will exactly create a sequence. Exactly, we want to create a sequence of 10 values. Okay, 10 values, and the range will 0 to 5. Okay, so suppose like this, I want 0 to 5. Okay, 0 to 5 is my range, and the number of values is 10. Okay, so I want 10 values with 0 to 5. Okay. So now easily we can print it. Yes. So print like this. A sequential array with 10 values between 0 to 5. So like this. So a sequential array with 10 values between 0 and 5. Okay. So here we'll keep a end line. Yes. And I'm calling my variable. So it will give us a float value. Okay. So I think spelling mistakes. Yes. Okay. Now we can see that at first start with 0. After that 0.5. After that 1.11. After that 1. But here you can see the difference is 5. Okay. After that 2.22. Yes. Something like this. If you want to the difference, I can show you the difference. Yes, minus the previous one. Yes, 0.555. Okay. So that is the working method of linspace. So after that, we will see how can we reshape our array. Okay. So what is exactly reshaping an array? So we can use reshape method to reshape an array, considering an array with space something like that A1, A2, A3 up till AN. Okay. So I'm showing you that what is its working purpose. So if once I show you, you will understand. So I'm taking an array like this. Yes. Inside this array function, I'm creating a 3 into 4 matrix. So suppose 1, 2, 3, 4. After that, yes, suppose 5, 3, 8, 4. Yes. After that, suppose 2, 7, 4, 8. Okay. My array is ready. Now, here I am creating a new array. So, array, here we will use the reshape function. Okay. So, this array dot reshape, that means, hey, array, please reshape it according to whatever I give in its parameter. So suppose reshape, yes. After that, so it is a 3 into 4 matrix. So at first we will give 3 into 2, that means it will create a 3 into 2 matrix. and it will split with 2. Okay. So if I print something like this, that the original array is yes, original array is our main array. Yes, that's okay. But our reshaped array, we want to see our reshaped array. Okay. So reshaped array is yes, like this, and reshaped array is our new array. So you can see here that here you can see that our array is divided into 3 parts. That means the first parameter is the split part. Okay. And after that, it create that 2 into 2. That means there is 2 into 2 matrix. So let's say that means first 1, 2, then 3, 4. So that is the first matrix. After 5, 3, okay, 5, 3, 8, 4. Yes, 5, 3, 8, 4. After 2, 7, 4, 8. But now here the total element is 12 because it's 3 into 4. So now I want to reshape it with two matrix, and the dimension is 3 into 2. So we can see that 3 into 2, 6 into 2, 12. Yes, it's okay. So if we do that, now you can see the matrix split with 2 matrix. So again, we can see 1, 2, 3. Yes. So 1, 2, after that 3, 4, after that 5, 3. You can see here. Yes. After that 8, 4, 2, 7, and 4. Okay. So I think so that is the row and that is the column. So if we change the row and column, that means 2 into 3. So you can see that 2 into 3 matrix. But if you give here a wrong parameter, that means 4 into 2, that means 8, 8 into 2. So it will not 12. So you can see here an error. Okay. So very carefully you have to reshape it. So it's very important when we will create an image into a ND array, that means a Numpy array. After that, sometime we have to reshape it according to its according to our model. Okay, where we train this type of image with the value of this of this type of array, because image is converted with this type of array there. Okay, so don't forget it, because reshape is so important. That is our main thing. Okay, so I think all of you understand this reshape function. So after that, we will see the flattened array. So what is the flattened array? It's nothing. If the matrix is 2-dimensional, the flattened function will create it 1-dimensional. That's simple. Okay. So let's check it up. What is flatten? So again, I'm creating an array. Array is np.yes array. Inside it, okay, two-dimensional matrix, something like this, 1, 2, 3. After that, yes. So 4, 5, 6. Yes. Already created. Now, if we call, suppose this is our, yes, this is a variable, and inside it, I am calling my flatten function. So flatten function, just a second. Okay. Flatten function will create this array into in one dimension. Okay. So we can see, also you can see, I'm simply copied. Yes, original array is array. And here, flatten array is our, yes, something like this. So all of you can see that this is a two-dimensional and make it one dimension. So a lot of array creation function already. What is that second two for in reshape array? Wait, just a second. So look at here. So I'm okay. I'm writing here a comment for. So see here what is happening. Okay. Yes. The first one is split number. Okay. That means how many matrix you want to, that means it will convert how many matrix. Okay. If you want 2, then there is 2. If you want 3, then there is will 3. But you have to balance according to your original matrix. That means if it is, suppose I'm showing you that it is a 3 into 4 matrix, that means 12. So you have to balance here. Whatever you give the value, that multiplication should be 12. Okay. So after that, the row number. Okay. After that, the column number. Okay. So again, I am showing you. So this is my row, that is 2, because second one is row. Okay. So row is 2. So you can see here reshaped array, the first matrix and its row number is 2, the first one and second one. After that, the third parameter is the column number. So you can see 1, 2, 3, 3 columns, and you split it into 2 matrix, 2 new matrix. Okay. So again, if we see that here is 3, that means you want 3 new matrix. That means now you can see 2 into 2, 4 into 3, that means 12. Yes. Yes, yes, yes. It's print random value each time. Each time it will create random values. Okay. So we will say see when we will do some hypothesis and p-values, then we will see with deeply. Okay. So now you can see, yes, you can see the split number is 3. So this matrix is split into 3 new matrices. Okay. So I think it's clear to all of you. Now we will going to see array indexing. So I'm give a comment here that is array indexing. So all of you know that this is our free course. So I will prefer you please join some paid course that you should learn better and deeply. Okay. So that is the beginner's level. Okay. That means you have to know about all the functions of those modules. That means sklearn, matplotlib, then numpy, pandas, then tensorflow, then tensorflow keras, then regression, linear regression, logistic regression, then how can we you split a data set for train and test with 80 by 20. Okay. So, okay, come to our topic. At first, we will see about slicing. Okay. After that, integer array index. And the final is Boolean array index. Okay. So let's see that suppose I'm giving here, we take an example of array like this. Yes, whatever you done before. And today I will announce a thing that means today's our session will continue up to 7:55. After that, we have a meeting for your internship session. Okay. So up to 7:55, we will continue our class. So keep patient and do with me whatever I doing here. Okay. Yes, I'm simply taking a example like this. I'm taking the negative value also this time. Okay. So 4, yes. After that, the second row is 4 like this minus 5 like this. 6 like this. Oops, here a mistake. Yes. It's minus 0.9 like this type of element. Okay. 2.6. After that 0, something like 7, 8. Okay. So this is a 4 into 4 matrix. 3 minus 7, 4, 2.0. Yes. So here we can see, yes, I think it's clear. Okay, yes. Now our example is ready. Now I am slicing the array with slicing the array with third bracket. So let's see how can I slice. After that I will yes. So inside this square bracket, I can slicing it into two parts. So all of we know that the first part is for the row and the second part is for the column. Okay. So if I give here, that means 0 to 2. Okay. 0 to 2. And after that, I'm giving like this. That means up to second column. Okay. So simply, if you see the output, you could understand what is happening here. Okay. So if we see that, please use returns and tell us. I'm not getting you. Okay. So array with, yes, first two rows and alternate columns 0 and 2. So what is it? So array with first two rows and alternate columns, that is 0 and 2. Yes. So if we do this and simply call our temp variable, so we can see that -1, 0, 4 and 6. Carefully see it. Okay. Carefully, that means first two row. Okay. So I am here initialize that with this colon. That means before the colon, if there is nothing, so it will initialize with 0. That means this, that means something like this, 0. Okay. So that means 0 to 2, not 2. That means this is our 0, this is our 1. Okay, that means first two row. Okay, and after that 0 and 2. That means second one. So that is my 0 and that is my second one. So that's why 1 and 0, and you can say 4 and 6. So I think you have an idea with how can we slice a array or a data frame. So is it clear, or we will see it in my drawing pad, something with more details? I need a comment, please. Suppose like this, if we give here a single column. Yes, okay. So what exactly, yes. So just a second, I'm showing you what is exactly its fundamental. So, okay, just a second. This is most very important. Okay. So once I show you, yes. So you can see there is a matrix that is 0, 1, 2, 3, 4, 3, 2, 4, 3, 4, 2, 4, 9, 2, 0, 3. So look here very carefully, whatever I show you. So all of we know that this is our 0. Yes or no? Yes, this is 0. This is 1. This is 2. This is 3. Okay. And here is also 0, 1, 2, 3. So this is our first column. This is our second column, third column, fourth column. Now, how can I slice it? So by I am this comma, I am separating. Here is the row and here is the column. Okay. Very carefully. Yes, not clear, but I'm clearing. Just a second. So that means when we want to slice means I need this 0, this 2, this 4, this 2 into a new matrix. That means 0, 2, 4, and 2. Just a second. Yes. So I need separate element from this our original matrix. Okay. So this is our total, our original matrix, and I only need this 4 element of this matrix. So that's why we using slicing. So we can, so this is my row and this is my column. So now you can see I need 0th row and I need 1th row, because my element is exactly in first row and second row and first column and third column. Listen carefully. Okay. So now how can I get the element? So if we put this comma, if there is a colon, listen carefully, there is a colon, that means this colon specify you the range. Range means, that means which row to which, how many rows you want. So I simply told him that I need 0 to 2. So 0 to 2 means not 0 and not 2. Only 1 is selected. Okay. But if we give like this, that nothing to 2, okay, nothing to 2, so the compiler will select 0 and 1, but not 2, up to 2. Okay. After that, I I already get my 0 and 1, okay, and all the element, okay. So simply you can see here, just a second, if I compile this, only this, so what what is exactly our, let's see, yes, only this, and we can see my first row and second row, we get total row and yes, second row. So that is clear, I think. After that, we need only this 1 and this 0, but not this 2 and 4. So how can we split the column? Okay. So that means here you can see. So if I define here double colon, look at here, double colon, and if I give here 2, so what will happen? That means I need all the column, listen carefully, I need all the column from 0 to all. 0 to what? 0 to all, because here is nothing, here is nothing, but 0 to all, but the difference is 2. Okay, yes, understood. Yes, 0 to all, but the difference is 2. That means the first one and the second one, only this. So if we give here a double colon, that means 0 to all, but difference is 2. That means here only the selected value is this, this, and this. Okay. So I think all of you understand. Yes. Thank you. Yes. So that's the exactly slicing method. Okay. Now, so again, we're doing some like this. Yes. Oops. Yes. So after that, that is integer array indexing example. I'm writing here a comment that you can understand. Oh, oops. Yes. So like this, here is a comment that this is our slicing. Okay. Yes. And after that, we will see like this, that this is our integer array indexing. Okay. So integer array indexing. Yes. So let's again take an example like this. Yes. So I'm taking an example with 2 into 4 matrix. Okay. So like this, that is 0, 1, 2, 3. After that, 3, 2, 0, 1. And you can, yes, like this. Yes. The reverse. Okay. So already, yes. Now, just a second. Wait. Yes. So this is exactly not our example. Already this matrix, so this array is this array, and I am indexing its position row wise and column wise. So let's see what is our main goal. That element after output, I will describe. So elements at indicates, that means 0 to 3. Okay. After that 1 to 2. After that 2 to 1 and 3 to 0. So that is the correlation. So you can see that something like this: 0 to 3, 1 to 2, after that 2 to 1, yes, after that 3 and 0, yes. So after that we will print our new temp. That is, this is our previous example. We can change the variable. That suppose a. So exactly this is for this example, and we want that 0 to whatever is 0 and third position, that means 0th row and third column. Okay, so look it here. If we print it, yes, so if I give a backslash n, so you can understand. Oops, wait just a second. Yes, and more backslash n, yes. Now you can see that 4603. So what is exactly indexing? So again, we will see here that this is our index. All of it can see this is our exactly index. So this is my 0 for column 0, 1, 2, 3 and 0, 1, 2, 3 for row. So if I here specify that 3, 3. So what is its position? What is the element? That means 3 go here to from here, and that is our 3, 3, that is 3. The element, the value is 3. So simply like this. So we are getting element from indexing correlation. Okay. So here you can see at first 0, 3. So 0 and 3, that is 4. Yes, understand? Yes, I think all of you can understand. You can see here 1, 2, that means 1 and 2, 2, that means 6, because it starts with 0. Okay. Our next thing is that Boolean array indexing. So all of you can see here some zeros. Here is 2, 0. Yes, make it again. Copy. Oops, there is a comment, that is Boolean array indexing. Okay. Yes. So inside this Boolean array indexing, so just this method is used when we want to pick some elements from array which is satisfied with some condition. So here condition is coming. So if I copy this matrix again and suppose I give some zeros here, more zeros, that this is 0, yes, and also this is 0. So yes, some zeros value. Now I keep a condition here that my condition is, hey array, give me the elements which is greater than 0. Okay, and ignore the 0. Okay, so something like this, temp is equal array of this condition. Okay, so you have to initialize it inside a square bracket. Don't forget it. Okay, inside a square bracket. Now, if we print that elements greater than greater than zeros, here is a backslash n, and after that simply we will print our variable. This is, so if we print it, yes, I have a mistake here, that will cond. Yes, so you can see all of the values but without 0. The 0 is missing inside this array. So that is a Boolean array index. So I think yes, error, that it's a spelling mistakes, don't worry. Okay, so I think three types of array indexing we already complete, and we complete reshape, we complete some array creations, function, and we complete the introduction of Numpy, something like this. What is the dimension? What is the shape? What is the size? What is the data type? So now we will go for basic operation. Okay. So basic operations, that is very important also. So let's start. Yes, basic operations. So operations on single array. So we will create a single array and we will do some operation with it. It's very simple. You can understand very easily. Okay. So after 7, we will take some 5-minute break, because all of you can understand a lot of time I'm taking class up to 3 hours or 2.5 2.3 hours. Okay, so we'll take at 7 p.m. a 5-minute break. So don't go anywhere, just 5 minutes. Okay, so here is, you can see, suppose like this, 5, 6, 3. Yes, now it's okay. It's a one-dimensional simple array. Now if we want to add addition, with some constant value. So it's pretty simple. How can we do that? That please print. I'm not writing anything. Okay. For your better understand, I'm giving adding. Suppose I want to add 2 to EV every element. Yes. And if we do that, yes, 1 plus A plus 2. And you can see 3, 4, 7, 8, 5. It's easy. After that, something like this, if you want subtraction, just print A minus 2. After that, you can multiplication square, then and double each element of original array, then something like this. And you can also, there is a most important things, that is transport matrix. All of you know that. What is a transport matrix? That row will change into column and column will change into row. So you know about transpose matrix? I need a comment, please. Hello? Yes, yes. Okay. So you can do like this, multiplication. Yes, multiplication like this. Then you can square like this, double. All of you know that the arithmetic operation, this is the simple arithmetic operation over a array. Okay. So we simply want to see something like this, that so like this, a transpose matrix, that I have to create a matrix again. So I'm not create, I will not create, I will simple copy from somewhere, that I can save my time. So I will keep one dimension more. Yes, like this. And one dimension more, that is 4, 6, 8, 3 randomly. Okay. So after this, now it is clear that we simply create a array, and that is a numpy array. So we have to, yes, like this. And the function parameter, all of you don't forget the function parameter. Okay. After that, so I want to print the original matrix. Okay. Again, I want to copy from here. Yes. Yes. The original matrix is A, and I want to create a transpose matrix. Yes, transpose matrix. So it will matrix, yes. Yes, matrix. Okay. Now, simply just A dot T, a capital T. So this T will change this matrix into a transpose matrix. Very simple. Just look at here. This is 0, 1, 2, 3. So it go here 0, 1, 2, 3. So the row will change into column, and the column is changed into row. So you can see that this matrix is 3 into 4, but after transpose matrix, it makes 4 into 3. Okay, so that's simple, pretty simple. Okay, so I think, yes, already it's 7 p.m. Just 5-minute break. Don't go anywhere. I'm coming with unary operator. After that, binary operation. After that, universal function. Some sorting array with. Okay. So that is our destination. More 4 module we will complete today. After that, tomorrow we will do some simple maths. After, we will directly move for some graphs, pie chart, histogram, scatter. Okay, so just we take a break of 5 Okay, so welcome back, students. Uh, so let's start our unary operation. So what is unary operation? So a unary operation, that means this includes with sum, what is the minimum value, what is the maximum value. Okay, row wise sum. Some function can also be applied row wise or column wise by setting an access parameter. So something like this. Okay, so give a comment here. That's why uh, don't leave, students, because this is important for all of you. Yes. So unary operators. So simply we will create an array for our example. Yes. And that is suppose 1, 5, 6. So oops, I got a mistake here. Yes, now it's okay. Yes. 4, 7, 2. After that, suppose like this 319. Yes. 319. And like this. Yes. Okay. So this is our example. Now, all of we know that about access. Yes. If access is 1, that means column wise. If access is 0, that means row wise. So let's see, suppose over all the matrix, what is the largest element? Okay, so I'm simply print largest element. To you need this. So let's have a funny funny example that where we need this. Okay, so suppose, just a second, what is happening? Yes, it's okay. Suppose this is a hacker. Okay, now this is suppose don't think like this, because it's only the education purpose. This is suppose the SBI database center. So what is the database center? So inside this database center, exactly all the customers' credential data stored there, already stored there. There all the details, name, then address, then debit card number, if he had debit card or not, if he using suppose checks like this, or like this using some okay, that UPI or something like this. So after that, his balance details. So actually this is the main focus of all the human beings, that balance. So suppose SBI one SBI branch has 1 million users. That means 1 millionth row. 1 millionth row. Now you have to find inside this balance, simple, inside this balance column, what is the, which customer has the maximum balance. This is a simple thing. So which customer has maximum balance, and you can see with simple one function, that is max. If you call balance.max, it will show you the maximum balance which customer have maximum. So it's only the educational purpose. So I think don't think like this. Okay. So yes. So here we will see what is inside the largest element, total inside this total matrix. So we just simply call array dot max, yes, like this. And if we print it, we can see the max is 9. And also we want to know row wise maximum element, row wise. Okay, row wise means this row which is the maximum, in this row which is the maximum, and in this row which is the maximum. So simply again print row wise maximum elements, that is simply called array dot max, and here inside this maximum function parameter, just give the axis is equal what? If I want to row wise, that means axis what? 0. Yes. So if I do this, yes, you can see here is 4, 7, and 6. 4, 7, and 9. Just a second. Where is come from the 4? Oops, it's come the column wise. Okay. So you have to give here, yes, axis 1. But I don't know about maximum parameters. So here you can see that the first row have 6 is the largest, then 7, then 9, and the third row. So if you want to print column wise, so just simply copy it and paste it. So that means column wise maximum element, and here is axis 0. Okay, so it will print column wise, that means 1, 4, 3. 4 is the maximum. 5, 7, 1. 7 is the maximum. 6 to 9. 9 is the maximum. After that, we want to need the sum of all these elements. So simply call array dot sum. Yes, 38. After that, we need a here is a very interesting thing. Okay. So where is the use? I will tell you later. So here is a function that is CumSum. What is it? CumSum function. It will calculate the sum with row wise. Okay, so just see an example here, that if I call that array dot CumSum, yes, array dot CumSum, yes, axis is equal 1, that means row wise. Okay, so if you do that, you can see, look at here, 1 plus 5 is 6. 5 plus 6 is 6 plus 6 is 12. After that, 4 plus 7, 11, and 11 plus 2, 13. So something like this. And if I want to do that with column wise, simply give the axis is 0. And you will see column wise, yes, summation. So there is 1, you can see here, where is 1 plus 4, that is 5, 5 plus 3 is 8. Okay, 1, 5, 8. Yes, it's okay. And that is our exactly the unary operation. After that, we will go for binary operation. So binary operation over array, or you can say matrix. Yes, something like this. So binary operation here, whatever Python program that is to demonstrate binary operation in Numpy. Okay, in Numpy. So we will exactly take two example. Okay. Oops, this is a comment, sorry. That's why, yes. So suppose our A array is, yes, inside it, suppose a 2 into 2 matrix 1 and 2, and just a second, yes, 2 into 2, so 1 and 2, 3 and 4. This is our A, and suppose our B is numpy dot array, and also here is a array that is 4 and 3. After that 2 and 1. Okay, so this is our simple 2 array. Now what is binary operation? That I want to add these 2 matrix element. So it's so simple that if you give A plus B, it will give that 4 plus 1, 5, 3 plus 2. That's all, nothing else. So that's something like that. The interview questions you can also, what is binary operation in Numpy? Okay, and simply A multiply B. Yes, 4 into 1, 4, 3 into 2, 6, something like this. But this is not the original matrix multiplication. All of you know that what is the matrix multiplication? Please give a comment here. I want a comment. Matrix multiplication. If you don't know, I will help you. Yes. Okay. All right. All right. So matrix multiplication, that means at first 1 into 4 plus 1 into 3, something like this. Then 2 into 4 plus 2 into 3, like this. So this Numpy has a simple function, that is dot function, and this dot function will give you the result of matrix multiplication. Okay, so that's simple, that a dot what I give, what I should give inside this parameter. I want to a matrix multiplication with b. So a matrix multiplication with b inside this parameter b. So if we do that, we can see the result. So it's different because it's the simple multiplication with the element according to its position, but this is the matrix multiplication. I'm commenting here that matrix multiplication. Yes. Now this is over. That's simple, pretty simple, or binary operation. Now we will see some universal function. What is universal function? Universal function, that means Numpy, this module, whole total module, provides some familiar mathematical functions such as sine, cos, exponential. All of you know, I think, the sine, cos. Yes. So all of you know about the sine, cos, exponential, etc. So let's see. Numpy has sine, and you can also you know the standard what is it? Yes, variations, and you can also do that with Numpy's module. You can do the minimum, that is in statistics. Yes, so minimum, that means min. This is a min function provided by Numpy. Okay, so something like this. All this method is from universal function that is provided by Numpy. Okay, so let's again, we'll take an example, but different type of example. What is it? So see very carefully. Our next day, after one day, I will show you the no, next day I will show you the hypothesis and p-values. There it will there is a use of this type of universal functions. So that is the array np.array, and we'll simply, at our first thing is 0. After that, np.pi. So what is the value of pi? Could you tell me, anyone? Pi in mathematics? Yes, deviation. Thank you. So what is the value of pi? Anyone? It's simple. Just remember and continue. Yes. So here I take 3 values. Look at here. One is the pi, another is pi divided by 2, and another is 0. Okay. So if I print this A, you can see here, this is the pi divided by 2 and this is pi. Okay. Now, one more thing, that if suppose simple that A is equal, simple here is a math, that if A is equal pi value, that means 3.1415 something, and if we print here the np dot sign of this A, sign of this pi value, so what is our answer? That is 1.224 something else. Okay, so that is our sign pi value. Okay, so now we will see over this array, whole array, we'll see the value over this whole array. That means after that, again I am repeating it, yes. Okay, and one more thing, that if I, that you can see where is my numpy is located, that inside the Python, inside my library, is inside my Anaconda library Python 3.8, inside the site packet there is numpy. Okay. So yes, so I'm simply run here sign A. So if I run it, it will give me at first the sign value of 0. After that, this value, that means this sign value. After that, pi sign value, whatever we getting in the previous cell. Okay. So now go for exponential and another matrix, that is suppose 1, suppose 0, 1, 2, 3, 4. Yes. Now if we simply call np.exp, that means exponential of this list of element. So you can see at first A on 2, that is the value. So you can use calculator to for the correction, that is it is right or not. So also you can root over square, all of you know that. So 4 root over square, root over 4, that means 2. Yes, we know that. So simply you can call numpy dot sqrt. Yes, okay, square, and inside its parameter just pass the array. Okay, pass the array, and you can see that this is 4, and for this 4 this is 2. Okay, and this is for 3, this is for 2, this is for 1, and this is for 0. Yes, so that is the simple things of universal function. And also you can see the mean, suppose like that, b dot mean. Yes, you can see the mean, that means 4 plus 3 plus 2 plus 1 divided by 5. Okay, is it okay? Now we'll go for sorting array, different kind of sorting, you know, merge sort, quick sort. So we have a nice parameter inside the np sort. Inside this parameter there is a parameter name kind, and this you can change the kind, that if you want merge set, it will give merge set. If you want quick set, just write quick set. Okay, so I am commenting here that sorting array. Yes, sorting array, and let's take again an example. Just a second. Yes. So I want to ask you all of you a question, that whatever I provide a data set that is Titanic.csv, I want the pandas methods and also the numpy methods. Just use inside this, use all the methods and function with this Titanic.csv, and I want to see that which is active, perfectly active, because who will perfectly active, he can only understand the deep learning and machine learning. Okay, so just submit inside our group just this file, this type of file, IPY kernel, that Python dot this type of file I'm showing you. Yes, this type of file dot IPYNB. Just post it. I will load it and I will check. Okay. So where we are inside the sorting. Yes. Suppose 3, 4, 6. That 0 minus 1, 5. Yes, like this. And this is a good example. And next we will see at first the simple sort. Okay, that means NP. So here is a print. I think we need a print. If we give the print function, this array will not print. Okay, and np dot sort. Yes, like this. Okay. Here is our example A. And suppose axis is none. So if we print that, you can see -1 to 6 up till to 6. Here is the 4 4 because double 4 is here. So it give me an array after sorting. Now another thing, that you can sort row wise. Okay, so how can you sort row wise? So just print, and I write a comment for you. Row wise sort. After that, simple call np dot sort, and inside this parameter, here you have to give the access. Access is equal 1. Okay, if you do this, so now you can see, oops, here yes. Now you can see 142, but here is 124. That means row wise sorting is done. After that, column wise sorting, and you can apply anything here. That means I'm showing you what I told you, that if you give a parameter that is kind, and kind is equal, you can give here quick sort, merge sort, whatever sort. Okay, just you have to give the correct spelling. Okay, so I am giving here merge sort. Okay, so it will save as like the sort. Okay, so after that I'm column wise sorting, so print, yes, column wise sort, axis is my 0. Okay, axis is my 0, column wise sort means axis is 0, and row wise sort, that means axis is 1. So now you can see that 1 3 0, so it is 0 1 3, you can see here. So you can apply this. Okay, you can apply this where you can apply this for a certain column. Okay, for a certain column, that means this type of columns, whatever we discussed yesterday, that this is a age, so you can sort it easily. Okay, so I think yesterday I show you the sort values function, sort values over object, float, integer. Okay, so yesterday we done it for exactly the object and according to the ASCII values. Just remember, or we don't need provide a Google form for submission. Yes, of course we can. I think the bot will help us. Don't worry, I will do that. So after that, let's take an example, sorting of structured array. Set alias name for its data type. Okay, so for this, yes, just a second, I have to take some list like this. Inside this list, so just look at here what I am doing. Our name with 10 characters. Okay, capital S. After that, so this is a tuple inside the list. After that, grade year, and that should be integer. Okay, it's data type. Okay, just focus here. After that, CGPA, yes, CGPA, and its data type is float, because we know that CGPA is 7.9, 7.5, 9, 9.3, something like this. So this is my data types. Already I initialize inside a list with the help of tuples. Now I'm creating some value. That means with the help of tuples, the name is suppose Giri. Yes, Giri. Oops. Yes, Giri, and his graduation year is 2009. 7.9 is the CGPA. After that, oops, Ajay, his graduation year is 2008. After that, CGPA is, oh my god, 9.0. Yes. And another one is Pankaj Kumar Nayak, 2008. And suppose if CGPA is 7.9. And the final one, that this is, suppose Rohan, one of my friend. Yes, 9, and his CGPA is 9.0. Now I am creating an array, and NP array. All of you know about this function, and values data types is equal d types that we create at first. So inside this, I'm passing the value. Okay, passing the value, and what is their data types. So that is another parameter. So that means d type is equal d types. That means this. Okay. So now my array is created already. Okay. Now I want to sort this array according to order. Okay. Now I want to sort this array according to its name. Okay. So how can you do that? So simply there is another parameter inside the sort function. That means array sorted by name, after that colon \n, and we can give that np dot sort, and inside this sort I want to sort this array. Okay, so this is clear that this array I want to sort. And what is this array? This array is this data list. But I want to sort it according to their name. That means A is the first of ASCII first one that in the ASCII table. So after the first come A, the second G, something like this. So now the order, that is name. Where is name? This is the name, and name all of these values at the name. Okay. So simply if I give name and look at here. Oops. There is a wait in wait keyword. Yes, here I fault because sort parameter, inside this sort parameter, one is array, one is order. Wait. Oh, because this is the first parameter of print function, so I should give another one. Yes. Now you can see that is Ajay at first, then Girikaga, then Pankaj P first, then Rohan. So according to its name. Okay, so name is objective, all we know. Now we want to sort it according to at first graduation year, after then CGPA. Okay. So at first it will see the graduation year, then the CGPA. Okay. So let's see. I just simply copy it and make some change. Sort it according to its graduation year and after CGPA. Okay. So now look at carefully at first graduation year. So the first priority is graduation year. Okay, it's okay. After that, the second priority is CGP. So at first, I will simply give here the graduation year, but inside a list. Okay, this is a single value, that's why this okay. With a quotation, this I passing this name. But here is multiple value, that means you have to start with a list. So at first graduation year, after that CGP. Okay. Yes. Now, if we run it, we can see at first 2008 to 2008. Nothing effect on CGPA. Okay. This CGPA is 7.9, less than 9. But our first priority is graduation year. So that's why it comes first. But if we do that like this, that at first CGP, after that graduation year. So then have a look, simply copy this. Yes, like this. Yes. Now you can say at first 7.9, then 7.9, there nothing effect on the graduation yet. Okay, so that is another order to sort the values. Okay, with this order parameter. Okay, so I think that is our time is already over. Yes. Because at 7:55 we have a meeting, so we have to finish today here, and that is all the NumPy introduction is that I covered in today's class. After that we will go for, I am writing here, we will go for converting, okay, converting image to ND array and ND array to image. So next day we will see it, and after that some simple mathematics, statistics, and variations and hypothesis. After that we will go the matplotlib module. This is our NumPy. After that we will go matplot library. Okay. What is, just a second. Where is the B? Which line? Oh, this B. Yes. I mistake something. No, it's okay. Yes, it's a good question. So yes, I will answer it tomorrow exactly. Don't worry. Why it is P. Okay, so let's stop here today. Tomorrow we will starting with converting image to ND array and ND array to image. Okay. So I'm ending this meeting. Thank you. Thank you all. Okay, thank you. Such a nice question. Yes, I not follow it. Why this be? Yes. Okay, don't worry. I will answer it. Yes. Thank you all.